How does AI actually work? Every time you type a message to an AI, billions of tiny calculations fire in sequence, and a response appears in under a second. But what are those calculations exactly? Let's clear something up. AI isn't searching a database. It isn't looking up answers. It's computing them by running your input through an enormous mathematical function. What you're looking at is a neural network. Each dot is a neuron. Each line, a connection. Information enters on the left and flows rightward through every layer, transformed at each step. During training, billions of these connections are tuned over and over until the network starts producing something useful. A neural network is a chain of mathematical transformations. Numbers come in, get multiplied, and added through layer after layer, and useful information emerges. These networks have parameters, individual numbers that control each transformation. GPT-4 is estimated to have 1.8 trillion of them. Training is just adjusting those parameters repeatedly until the network gets good. AI doesn't read text the way you do. It first breaks everything into tokens, fragments it has learned to recognize. ChatGPT isn't one token, it's three. ChatGPT. The word unbelievable splits at its natural boundaries, un, believe, able. And transformer architecture may tokenize in ways you wouldn't expect. Every word you type is first reduced to a stream of these fragments. AI doesn't read words, it reads tokens. Tokens are chunks of text the model has learned to recognize. The word unbelievable might become 3 tokens, un, believe, able. At every step, the model runs the same calculation. Given these tokens, what comes next? For the capital of France is, it generates a probability distribution across its entire vocabulary. Paris scores 72%. Everything else is a distant fraction. The model samples from this distribution, which is why responses vary slightly even when you ask the same question twice. At its core, a language model does exactly one thing. Given a sequence of tokens, predict what comes next. Every response is generated 1 token at a time, each choice based on everything before it. Here's the problem attention solves. When predicting a token, which previous tokens actually matter? For Matt in this sentence, the model looks back and weighs each one. Sat is most relevant at 35%. On matters 2, 25%. The others, far less. Attention lets every token scan the full context and find what's useful. This single mechanism is what made modern language models possible. The transformer architecture, the T in GPT, uses a mechanism called attention. For each token, it calculates how relevant every other token is to predicting the next one. Modern language models stack 96 or more of these attention layers. Each layer learns different patterns, grammar, facts, reasoning, building up richer and richer representations. The training data for GPT-4 is estimated at 13 trillion tokens, essentially the entire indexed internet, plus books, code, and scientific papers. Through that training, the model compressed a representation of human language, knowledge, and reasoning into 1.8 trillion parameters. It's not stored like a database. It's encoded, baked into the numbers. It doesn't understand language the way you do. There's no comprehension, no experience, no inner life behind the words. It is, at its core, a very sophisticated pattern completion engine. But here's the thing. Language is patterns, and being extremely good at predicting what comes next, at a massive scale, produces something that looks a lot like intelligence.